So today we're going to look at file sizes with image files and audio files. So firstly, looking at image files, what we need to know is how many pixels there are and the bit depth. So firstly, we take the resolution. So this image here is 3000 by 2000 and it's a 24-bit image. The second one over here is 1000 pixels wide by 666 pixels high, and it's an 8-bit image. So we take for instance, 1000 times 666, times those together. We multiply it by the bit depth, which is 8-bit. We divide it by 8 to get the bytes. And then to get in megabytes, we divide the amount of bytes by a million. So what does that mean in practice? Well, as I say, this image is 1000 by 666, which is clearly 666,000 pixels. And we know that the amount of bits is 8-bit, so we need 666,000 multiplied by 8. And that, I've done the maths beforehand, is 5,328,000 bits. Because every pixel has got 8 bits to it. To work out how many bytes that is, we now divide this number by 8. Because there are 8 bits for every byte. $666,000, ironically enough, because we've times by it then divided by it again. Finally, in order to get the amount of megabytes, we need to divide this number here by a million. So 666,000 divided by 1 million equals 0.66 megabytes. Now, with our second image, we know it is 3000 by 2000, and it is 24-bit. So again, we do 3000 times 2000, which gives us 6 million pixels. So 6 million pixels in this image. We need to times that by the amount of bits in every pixel times 24. That gives us 144 million bits. Finally, to work out how many bytes that is, we need to divide this number by 8. You're finding dividing by 8 quite a few times in these file size questions because the amount of bits to bytes. So you need to get that part into your head. So we've got 18 million bytes. Finally, as I said, we need to work that out into megabytes. So we divide by a million, gives us roughly, or exactly in this case, 18 megabytes. Now your computer may show something different to this. That is because Windows 10, and in fact all Windows and most operating systems, produce and show storage size in an older style version of kilobytes and megabytes, where it's designed as 1024 kilobytes in a byte, 1024 megabytes is a kilobyte. However, about 10 years ago, it was decided that file sizes would be shown as standard unit of measurement, whereas 1000 kilobytes is a megabyte and 1000 bytes is a kilobyte. So that's sometimes where you see some discrepancy when you buy external storage and it doesn't show as much as you thought. That's why that is. Secondly, we've got file size in sound files. So this one's a little bit more complicated, but again, it's just multiplying. What you need to do is find out what the frequency is, and that's how many samples or measurements of sound are recorded every second. Right, with this, I need to move a bit further down the screen. So how many samples, measurements of sound are recorded each second? And again, we have a bit depth. So it is the range of different values that each sample can be. And that could be, for instance, let's move that, delete that, get that out of the way. For 16-bit, there's 65,536 different possible values per sample. 24-bit, you've got over 16.5 million. So they're the different ranges, almost the different amplitudes that your sound file can be. Finally, you have channels. As you know, you can get stereo, you can get mono, which is just one channel, or surround sound sends the sound out to lots of different places. So, all we need to do is multiply all three together. Gives you the file size in bits per second. And it's really key to notice that's bits per second because it's samples is measurements of sound recorded each second. Okay? So you find out the bits per second, and then you multiply it by how long the song is. So it'll be in seconds, and that gives you the amount of bits. Then you divide by 8 and divide by a million. If you're stepping ahead, you can obviously divide by 8 million. But for these purposes, I'm just taking you step by step through, because if you know the bytes, then you can work it out in kilobytes, megabytes, whichever way you need. So let's look at two different examples. And just to note, these are WAV files, not MP3s. This is like a lossless way of encoding, so you don't lose any data. MP3s, you lose some data, so that the file sizes will not be this size. Now, a 4-minute song, we need to take the 44,100 times it by 24 times it by 2, because it's stereo. And that gives us 2,116,800 bits per second. Next, we need to multiply it by how long the song is. So we've got our 2,116,800 times by 240 seconds, because our song is 4 minutes long. And that now gives us 105,840,000 bits. That's how many bits the whole song is. Clearly we need to divide it by 8. So take this number and divide it by 8. Gives us 13,230,000 bytes. Or divided by a million, 13.23 megabytes. So again, it's very similar to the image files. You're multiplying the key bits of information together. Now we've got an example of a lower fidelity sound file, 22,000 samples. It sounds like a lot, but you will start noticing the different quality of the sound. 16-bit is actually CD quality, and 24-bit is high definition audio like you'd get in a DVD or a Blu-ray or something like that. Mono, just one channel, it's a 5-minute song. So again, we've got 22,050. We multiply that by the 16 bits, multiply that by 1, so you don't even need this bit here, because it's mono. And that gives you 352,800 bits per second. If we then take that number and times it by 300 seconds, that's 5 minutes, that gives us 105,840,000 bits. Finally, we need to divide this by 8 million. Okay, so divide by 8 first gives us, you'll notice that I'm about to make a mistake here. So it's 13 million bytes or 13.23 megabytes. On the previous example, I looked at the wrong page of my notes. Answer up here is actually 508,032,000 bits, which eventually gets to 63,504,000 bytes, or 63.504 megabytes. Apologies for that little mistake, but the maths is exactly the same. Multiply the samples by the bits by the amount of channels, so stereo in this example, and multiply it by the number of seconds. And that should give you the file size. And that is the basics of how to work out file sizes. Make sure that when you're reading the question, if it asks you for the answer in kilobytes, you give them an answer in kilobytes or megabytes. Just make sure reading the question is very important, because if you misread what they're asking you, you could end up giving the wrong answer, even though you know exactly how to do it. So have a go at the questions and we'll see how you do.